introduction. My name is Christine Shepard. Thank you so much for coming out here tonight. My background, I'm a photographer, I'm a scuba diver. I've been working with scientists since I started my career a few years back. I love working with marine scientists especially to help communicate their research to the public. And after moving out here to Hawaii a few years ago, started a media production company. And I'm always looking for fun projects to do that brings me back into the science world and connects me with that, and just that sense of discovery and being on the cutting edge of technology. And this project here that I'm going to be talking with you about today kind of combines all of that: photography, wildlife conservation, science, technology, and education, all wrapped up in one. So without further ado, I'll get started here and we'll get going. So how many of you guys have ever heard of the topic or the concept of digital heritage? Not many. So heritage, as defined by UNESCO, is our legacy from the past, what we live with today, and what we pass on to future generations. So it's this idea of what do we value right now that we want to be able to pass on to the next generation. And so it can be a very broad umbrella term. And one of the more popular movements right now is cultural digital heritage. So there's this amazing organization called SCIARG that is really leading the way with preserving significant artifacts, monuments, buildings, and archaeological sites like Mount Rushmore here, using 3D mapping, but they use laser scanning. And so it's a way to then create a very, very accurate 3D model of these historical places or these significant monuments that they want to be able to educate people about that can't go visit it, but also potentially to preserve it in case anything happens and they want to be able to rebuild a replica of it. They've been doing a lot of this in the Middle East and areas where there's a lot of war happening and a lot of buildings and monuments that are thousands and thousands of years old. They want to preserve them. So scanning them in case they are destroyed to potentially rebuild them. So what about digital preservation of life? It's kind of a bizarre concept because obviously life is living, so how do you really digitize it and why? So this is a concept that our team at DigitalLife has been exploring, and we'll be getting into a little bit more here. So why create 3D models of life? With DigitalLife, we're covering three main topics here: conservation, education, and science. So this little guy here, unfortunately, is now extinct. His whole species, gone, as of September. And one of our collaborators, Joe Mendelson, wrote this article for the New York Times back in October, talking about how this one species is now gone, and it's due to a lot of different reasons. But there's a number of different infectious diseases going through around the world that are really attacking amphibians and having a huge impact on their populations. So what some zoos, like Zoo Atlanta, have done is they collect a couple specimens, bring them into captivity, and try and work on captive breeding. But this guy they couldn't figure out the mystery of how to get this species to breed. They tried. And of course they documented it in photos, but we don't have a way to really show people physically what it looked like. So exploring concepts like that, how can we really preserve the digital heritage of animals like this that are now gone? And there are certain species that are definitely more vulnerable to extinction right now, like the white rhino and the tigers, that definitely face a real risk of extinction in our lifetimes. So what are we doing about it? There's people coming from all different angles at this issue, and we at DigitalLife are looking for a new angle of how we can help. So one solution here that we're exploring is creating a collection of accurate, high-quality 3D models of life on Earth. So animals, plants, and other organisms, in order to support those three main principles here: innovative wildlife conservation, hands-on immersive education, and also open access science. So here are a few sample applications. So what does that actually look like? So imagine for a wildlife conservation, you're going to this high-profile gala in New York City, this big ballroom. You walk right in, you're all dressed up to the nines, and as soon as you walk in, you see this giant 30-foot hologram of a leatherback sea turtle. That's a showstopper, right? And it will connect people to these animals that they can't bring a leatherback sea turtle into the middle of a ballroom in New York City, right, if they're working to preserve them. But how you connect people with the animals. So we're exploring different digital media to connect people with these animals. Education. Imagine you're going into your high school biology class to learn about, say, predator-prey interactions. And today you're going to talk about the tiger shark. So maybe not everybody's gone out in the ocean and seen one yet, so how do you learn about it? Right now it's maybe textbooks or photos or some videos, but imagine if you could put on a virtual or augmented reality headset, and all of a sudden you have a 16-foot tiger shark in the middle of your classroom that you can walk around, you can look at the gills, you can look at the teeth, you can look at the stripes, and you can talk about the morphology of these animals, the shape, and how that affects their ability to carry out their job as predators in the ocean. And now on to scientific discovery. So we have a lot of scientists in the room. And as you know, field work is expensive, it's difficult with permits. Sometimes nowadays it's not even possible to get permits to work with the animals that you want, especially if you want to bring back specimens to study in more detail later. So we're exploring this concept of what if we can bring back a digital specimen of an animal that's in a very hard to reach place so that we can study it in more detail in the lab later on. Looking at morphology, so body shape, and looking at, for example, how an animal is hydrodynamic, swimming through the water. If you're running computer models right now, you have to create that model yourself. But what if you could just take an actual 3D model of that animal and run it through these tests to learn about how it moves and how efficient it is in the water? And the other thing with that is a lot of museums, they have these specimen collections, but they're jars in a silo, basically. It's hard to access. So with these, it's something that you can share around the world. We create it once, but then scientists from all over the world can access it and study it and share it. So in that way, we're really looking to support the open access movement with science. Okay, so now, how do you scan a live animal? Probably wondering that. And more importantly, how do you scan live animals in the wild? So there obviously are some issues, like there's water and they're moving, they got big teeth. So how are we gonna get it to sit still long enough to maybe do a laser scan, to do all these different things? Well, we want them to be live. So we're actually using a principle called photogrammetry. And this is something that's been around for a long time and used in a lot of different utilities, but recently it's seen a real revival because of a couple main companies, Autodesk and Capturing Reality, that have awesome software that just keeps getting better every year. And so the concept is that you take a picture, let's see, we've got this cute little seal here, okay, with the leg, yeah. So if we want to do a scan of this, what we need to do is take a picture from every single angle, all the way around, underneath, up close, far away, and then we take those photos and we put it through one of these software programs. And it will actually take the 2D photos, stitch it together, connect the dots. It will figure out where the camera positions were. So every one of these is a camera position, and the computer figured out where the camera was based on the overlapping information from all the photos. And it stitches it into a 3D model. So that as you can see here, these are little thumbnails from a monument, and then those photos are then put in there, and then it figures it out. So I'll give you another example here. So here we go from photography. So this is a giant marine toad. It's like 12 inches to give you a scope. It's pretty gnarly. And we got cameras all around to take pictures of it. Then we put it into the photos, into the computer, into the software, and it outputs a 3D mesh. So 3D mesh is basically information on the texture and the shape, and it uses all these vertices and little polygons. And as you can see, this one has around 650,000 faces, little polygons that make this up. It's a lot of information. And then it takes the actual color from the photos and puts it on top of that mesh. So not only does it figure out the shape and spatially and the ratio of all these measurements, but then it puts the color on it. So then you have the texture, the shape, and as well as the accurate color and pattern of the animal. So a little bit of an overview for the process and the concept of model production within DigitalLife. So like I mentioned, we use Photogrammetry, which takes 2D models and turns it into a 3D model. Sorry, 2D images and stitches it into a 3D model. And how we do this, how we are able to really tackle such a big challenge as 3D modeling live animals is we collaborated from lots of different disciplines. Scientists, engineers, photographers, artists, computer modelers, all coming together, bringing their expertise to try and solve a lot of problems that come up when you're trying to do this. And then how do we gain access to these animals? Being that we come from a background, the leadership team of DigitalLife comes from a background primarily of academia and research, we wanted to make sure that everything we were doing ethically and with the well-being of the animal in mind. So we're forming strategic partnerships with other field biologists and scientists that already have permits to work with the animals and are doing it in a very ethical way, with zoos and aquariums that have strong research components to them, and working with them to leverage that so that we can access these animals. So here's another one. This is a tokay gecko, pretty popular in the pet trade. Beautiful, beautiful animal. And you can see this is actually a still image from our 3D model. It's not a photo. This is the 3D model itself. And see underneath it, 6 million faces. Just look at the texture on it. The more texture and the more intricate design on it, the more faces it's going to take to actually represent it fully. That's the level at which this technology has progressed. It's pretty incredible. Yeah?
So I love the visual texture. What about like the feel of it? You actually touch the image. Does it feel like the animal?
So you're talking about basically if we were to print it out, 3D print it, will it feel like the animal? It's a really interesting question. We haven't really explored that in a big way yet. We've just started doing 3D printing, and I guess it would depend on the media with which you print it. And I mean, I doubt it will ever feel like the animal unless you really get into it, and perhaps that's where artists come in to collaborate with us a bit more. So how to create skins, you know, to really take it to the next level. That's a really awesome thing to think about. And this is why we need lots and lots of minds collaborating on this type of thing, because they think of things that, you know, from their own disciplines and their own experiences. So how do we do this? Sorry, the formatting got a little weird here. Okay, so our BeastCam technology, that's the technology platform that our engineers have developed, and that basically is this multi-camera platform to rapidly capture 3D models of living animals. And over the last couple years, we've gone through lots and lots of variants of this technology to get where we are. But the main thing is it's able to adapt to a variety of environments and subject sizes. So right now we have enough platforms, we have enough platforms to go from an animal that's about ½ an inch in length all the way up to 6 or 7 feet in length right now. And so that adaptability is a huge component of the technology here. And the other big piece is portability. So not all animals we can bring to us in a lab. The main lab that we have for this is actually at the University of Massachusetts in Amherst, Massachusetts. And so we can't bring a lot there, but we have to go to the animals, whether it's the zoos or whether it's in the wild working with field biologists. So we needed the technology to be very, very portable. This is our main engineer here. And so every system had to be created with that in mind, that we'd have to break it down and put it back together very easily. So just a few of the challenges that we've gone through. Did you still have that question?
Yeah, could you theoretically take video instead of picture so you have a moving model?
That's where we're headed. Yeah, it takes a lot of computer space, a lot of computer power, and the software is getting there. There's nothing really widespread and out there, but that's definitely where we're headed. Yeah, really awesome thought.
If you did not have a specimen, but you did have a lot of photographs, can you work backwards from that, or is it?
If the photographs were taken at the exact same moment, yes. But if the animal is moved in any way, whether it's breathed,
Well, I was thinking of perhaps not the same animal. Maybe let's say a white rhino. Maybe there are probably hundreds of thousands of photographs out there of white rhinos taken by different people, different times, different places. Or I was actually thinking about some Middle Eastern artworks that have been destroyed but were photographed.
it's really interesting. I think the artwork has more potential that way because one of the main things with the software is it uses the background as reference points. So if you're taking a picture of this guy here doing a scan of it, but say one of you guys got up and left in the middle of the scanning process, it's going to confuse the software because it's going to use everything around it as reference points to figure out where everything overlaps. So in that sense, I don't think the animal would work as far as I know with the limits of photogrammetry right now. But the artwork, if it's in the same spot on the same wall, possibly. I'm not sure.
So
Good thought.
what about the ventral side of the animal?
Yep, so we are working on that and have some exciting things in the works. Nothing that we have quite released yet, but that's definitely one of the main things. So our current projects, which I'll get into in a little bit, the frogs of the world, we're doing it on a substrate, and so that's the goal for this project. But for, you know what substrate is, right? That's the floor that it's on, sorry, little term there. And but for the sea turtles, which is our other big project, we want to do whole body models. So we actually have to flip the animal upside down and do the same scanning process. And then we use 3D modelers, computer modelers to stitch it together.
Not just a glass floor then that you're shooting up underneath.
We're working on that. It's, yeah, there's a lot of logistical components to fine tune with that, but we're headed that direction for sure. Awesome. Good questions, guys. We should have a focus group with you guys next time we're trying to figure something out. Okay, so here's a close-up of the actual array. So the array is our kind of intermediate size camera setup, and it can hold about 40 cameras. And right now we're working with kind of like a midline Canon camera that's compact, but it actually does what we need. Some of the fancier cameras, as you get into DSLRs and all that, if we have any photo people in the audience, something that makes a good artistic photo is the exact opposite of what makes a good photo for photogrammetry. Photogrammetry is very, very technical, and you want everything to be in focus. Remember how I was talking about using different things in the background as reference points? Well, in order to do that, you have to have everything in focus. So if you see those artistic photos where it's just a little bit of the animal in focus and everything's blurred out, that's horrible for photogrammetry. And the computer's not going to like you. So you want everything in focus. The more detail, the better. So sometimes these kind of cameras have actually worked better. So it's good for us with getting started. And to give you kind of an overview of the framework for our organization right now. So we're creating accurate, high-resolution 3D models of life on Earth. We're partnering with scientific organizations like zoos, museums, other researchers to gain access to them, but also to focus on animals that are of extra significance, perhaps conservation value because they are threatened to go extinct soon. And or maybe it's animals that are under a lot of threat right now, and conservation groups are wanting to put together big campaigns to raise awareness. That's where we come in and want to partner with these organizations to help them by providing novel media that then they can go use in the public and gain extra attention and get people really emotionally wrapped up in the animals to help and want to help the cause a bit more. And then the third piece of our framework of how we're setting up is distributing the models. So the models are only so good when they're on our computers. They have value when we get them out there. So that's a big piece we're working on, and I invite all of you guys to rack your brains of who might be interested in working with these models. So in the nonprofit context, whether it's school groups, museums, different scientists that are studying the animals and want to have 3D models of them. I open up all ideas here, because that's where we really create value here, is when these models are being used for good out there. So what makes us different? I've touched on a few different of these topics, but just to outline it a little bit, because if you were to go do an online search of 3D animal models, there's going to be some really cool ones out there. But the difference is, all of them are artistic renderings. None of them are fully accurate from real life. So they look really real, but if you were to get into the minute proportions of things, how the fur lays down on different tiger, how the stripes and patterns, it's an artistic interpretation of what that animal looks like, which can be very, very beautiful and realistic in a lot of ways, but if we're looking for scientific accuracy, that's where we're going to come in and be a bit different here. Also, our technology that I showed you, our BeastCam array, it's a very portable platform and it's very adaptable so that we can scan, because life on Earth is so diverse. Our job is never going to be done because there are so many different types of animals that have unique challenges to scanning, like a shiny animal. It's next to impossible to scan right now, but we're working on figuring out new ways to do that. So there are limits to the process that we're trying to problem solve and figure out. So that adaptability is huge. Scientific metadata. Our thing is not just about creating something beautiful, but also something useful. So collecting measurements and the species names and locations and as much information as we can to add context to the models so they are extra useful, whether it's for education or science or any of that. Also, our interdisciplinary credibility. So because we care about working with reputable institutions and conducting ourselves at a very high standard, we make sure that all animal handling is done under permits and regulated very, very closely. So that's something that is going to be a big differentiator moving forward. Although at the moment, we really are the only group working on this at the level that we're working on. So I think that's pretty cool in that it's really cutting edge. Full color models. So using that laser scanning technique that they use for buildings, they actually have to go in and kind of add the color later on. But using photogrammetry, it adds that in naturally through the process. So we get those real life colors and patterns that nature has so beautifully and perfectly created with all these different species. So including that in there. And then also our focused mission. So there's a lot of people doing amazing things out there in 3D modeling. But I think one of the things that differentiates us is that we have decided to solely focus on living animals, plants, organisms, life on Earth. So having that focused mission, we are really specializing in this niche. So hopefully we can help other people as they try and solve it for their own research, for their own museums and this sort of thing. We can help lead that and really provide high quality digital assets. So brief overview, our leadership team. I'm basically the blonde sheep in the group, and it's 3 academics from the East Coast here. Duncan is our director, and he's done some amazing work with a startup called Extinction. So he studies geckos and how they adhere to things, which we know a lot about here in Hawaii. We see them all the time, but it almost seems like magic how they just hold on and they don't leave any stickiness behind, right? So he's studied that in great detail and actually synthesized a material that is bio-inspired from geckos and is working on commercializing that right now called Extinction. Super cool. Andy, he's an amazing fisherman, studies fish biology, both fresh and salt water, also works with documentaries. Neil is our go-to shark expert. If any of you saw my presentation a year or 2 ago here, talked a lot about shark research. That was the guy that I did it with. And then I kind of was bringing in more of the photography side, a little bit of the commercial perspective. And so yeah, that is our fearless leadership team. But we also have a ton of other people that are collaborating, and we're always open to expanding and partnering with more people. So like we have an advisory committee, technical and educational advisors, scientists, engineers, animators, photographers, artists, lots of students from undergrad, graduate, moving on. So we definitely love to work with people from lots of different disciplines and perspectives, because I think it's only going to enrich what we're doing and enhance it. So our current campaigns that we're working right now on, which I mentioned a little bit, I'm super excited about them. We're working on Sea Turtles of the World, which I'm sure there's a lot of Honu love in here, hopefully. But we're going to be working on with all 7 species from around the world. That's our goal here, and I'll get into that in a minute. And then also frogs of the world. So our goal with the frogs of the world is to create high-quality body-on-substrate, there's that word again, 3D models of about 40 or 60 representative species. So some of the more common ones, but also some very rare, endangered, going extinct ones too. And we're working with different field sites, both in the wild and at some zoos currently, that have those captive breeding programs with scientists and conservationists working together. And yeah, so we actually just did a trip to Zoo Atlanta this last month, and successfully scanned nearly a dozen different frogs. And I'm going to show you some models in just a minute. Super, super cool. But that little guy down there in the middle is the Panamanian golden frog, sorry. And it's actually believed to be extinct in the wild. But they have them in captivity and are working on breeding them. And we were able to scan one of those guys. Super, super cool. And sea turtles of the world. So that is where we are headed. And working with all 7 species, and where that comes in about asking, are we doing just the top for the top and bottom? So these ones, we are going to be doing top and bottom for. So pretty ambitious, but something we are definitely ready to do and tackle. But in order to get to these guys, we're going to have to travel around the world, because certain species, anybody know which species is in Australia? We'll start with our high schoolers. Anybody? Okay, we'll open up to anybody. Anybody know the species that's only in Australia? Oh. The flatback. Oh, you're the Aussie. I know. Almost. Okay, so there's a turtle that is only found in Australia. But then also we're going to be going to Florida and Costa Rica, which have a lot of different species that nest there as well. And we're working with partners like World Wildlife Fund in Greece, James Cook University in Australia, and then a couple organizations in Costa Rica as well to gain access to these animals in the field and at rehabilitation centers out in Florida as well, to hopefully capture these animals in 3D at different life stages as well as the different species. So hopefully by the end of all of this, we will have basically cataloged all these different sea turtles from around the world, so that scientists can really delve into questions that they so far have not been able to figure out, because just the logistics. So pretty exciting stuff. And I am going to show you a video to go with that. All right, hopefully audio will be good here.
At DigitalLife, we create accurate, high-resolution.
Signal disappeared. Let's try that again. Any thoughts?
Is it in your presentation?
Nope. It's just there.
Coming.
I'll put it on the desktop and just open it up here.
Yeah, let's just check.
Bear with us for just a second.
But I think it's okay.
There was an upgrade message in the corner of the screen.
Oh, that happens every day.
Please don't go into that.
Question?
Yeah, let's answer questions now.
Yeah, I just have a quick question.
Sure.
I'm wondering if you ever anticipate incorporating like X-rays or MRI imaging to make your 3D model more than skin deep.
Yeah, that is definitely the next frontier. It's not something at this point we're focusing on, kind of getting back into that specialization, because what we're doing is so complex in itself. We want to make sure we're doing that really well first before we add in more complexity. But it's definitely something we'd be very interested in. So if there was a partner that wanted to come in and work with us on that, hint, hint, anybody, we definitely would love to explore that idea. Yes.
How do you do the interior, like on a crocodile, where he opens his mouth and you can see, or a lot of the animals? I mean, I see what you're doing. You're doing all the exterior. But what about
A little
the
holes in the
interior mouth?
noses.
I mean, how do you do that when they don't hold their mouth open?
Yeah, so we have, as we've gotten started, there's, like I mentioned, enough complexity in what we're doing that we wanted to start with things that were definitely achievable and doable and work our way up to the more complex issues like that. So it's not something we have figured out as of yet, 100%, but we're definitely headed that way.
So you're thinking about it. Right?
Yeah, we're moving in that direction. Yes.
So I'm assuming if all the cameras snap at the same time,
Uh-huh.
so if it's something like an open mouth, you can get it
You
in
just
its
need
open
one
position.
split second.
Yeah, yeah. I mean, especially if it's certain animals that are used to, that are in a zoo or something, and for veterinary checks are used to having to open their mouth or that sort of thing, we would probably do a couple of separate scans and then in the computer stitch them together. I'm sorry, you had a question too.
You can already do that. That's why if you get an MRI, you should get your get it on the data on a disk. It's a DCIM standard, and then you can go home and like build your brain. And what's going on now is the doctors are doing difficult operations in 3D print first. So you want to get your medical records of, you know, this is a matter of kind of insurance, and it's really computer intensive, but it's not too hard to do.
Fascinating. Sounds like we have some things to talk about. Awesome. Yes,
Does the system work underwater yet?
we're working on it.
Because that's a lot of housing and everything else involved in animals swimming, obviously, so they don't really sit still.
Yeah. So we've definitely got some rigs in the works for probably 2018 is our goal. Yes.
Quick question, there's scientists that are studying specific animals. Right now, there's a kapu, which means a parrotfish.
Sorry,
The
continue.
parrotfish is, out of all the bleaching on the pearl, they finally realized that the parrotfish gets hunted at night and speared, but that's the fish that eats the dead algae on top of it and grinds the coral.
Yeah.
So they want to now go after that campaign. So my question is, if you wanted to fund that, how much would it cost, like, to do something for a science research trying to promote just a ballpark? Like,
How much would it cost to do a 3D scan of that?
of a fish, in that particular case that we
Yeah, I would love to talk to you about that. I can't give you a figure right off the top of my head here, but that's something that we definitely are interested in working with people on.
And you can do that, like, even though it's a fish, I mean.
We're working toward that. Yeah, we actually have one of our grad students just worked and successfully took basically a dead fish and scanned it, and then took photos from a live fish and was able to impose the coloration on it that way. So certain species that won't sit still and that sort of thing. So we're exploring a few other options of how to do some of the harder to reach animals. So yeah, definitely happy to talk to you about that. So is it okay? I'll answer your question just a sec. I will, let's see. Can I do this?
Yep, you should be able to do that.
You're all set. Sweet. Thank you guys so much. At DigitalLife, we create accurate, high-resolution 3D models of living animals to benefit science, conservation, and education. And with this project, we're going to be creating a collection of sea turtles of the world 3D models that you can view online, you can print them out, and you can even view them in virtual reality. We have an incredibly diverse team that we've put together for this project. We have internationally renowned sea turtle biologists to help provide field access to these animals around the world. We have engineers, professional photographers, artists, and we're all bringing our strengths together to push the envelope of what's possible with 3D photogrammetry.
Creating 3D models of live animals is really challenging because animals move, they breathe, they often can be hard to access, it can be in remote locations. So the BeastCam technology is really distinctive for several basic reasons. It's portable, it's a flexible system, But it's also a system that's really custom designed for animals. We have rigs of different sizes that work anywhere from about ½ inch in length to 6 or 7 feet in length.
These systems are always going to be evolving. They're never going to be finished because life on Earth kind of has an untold amount of variation. And so our systems need to be completely variable and interchange on the fly.
To get started, we've already created some amazing models that you can go view on our website, DigitalLife3D.org. We have a black-tipped shark. We have crazy frogs of all different sizes and shapes and colors. We've got snakes, scorpions, all these amazing animals. And sea turtles are going to be our next frontier. Now more so than ever, sea turtles face numerous threats, from climate change to habitat loss, ocean plastics, and even over-harvesting.
Our goal here is to create 3D models of all 7 species of sea turtle. In order to do that, we're going to have to go all around the world to places like Australia and to Central America and to work with sea turtle biologists to access these animals, to create 3D models of them, and then to really highlight their beauty and their fragility, and to work with conservation agencies to promote conservation of these amazing animals.
Educators can use these 3D models of sea turtles in their classroom as printed 3D models or even in virtual reality to learn about sea turtle biology and morphology.
By creating 3D models, we can then test scientific theories for how these sea turtles migrate, how they move. And we can even reconstruct sea turtles that we may not have access to at all. And by doing this, we can really test some long-standing theories in sea turtle biology that have really remained outside the realm for most scientists.
We're doing what no one on this planet has done before. We're creating accurate, high-resolution, full-color 3D models of live animals.
As a nonprofit initiative, we need funds to complete our work. For example, funds for travel, for production costs, and for equipment. And we need your help to make this a reality.
Join us as we digitally preserve the heritage of life on Earth, using cutting-edge technology and making wildlife viewing and learning even more accessible and experiential, from the science lab to the classroom to your home.
Upper right corner there.
Let's see. Awesome. So now I would love to show you a couple models here. Okay, this is confusing. Any idea how to get the back back to the screen so that I can show these? In the meantime, while we're getting that figured out, I'm going to pass around a 3D printed model of a Fowler's toad that one of our University of Massachusetts students hand painted. And so take a quick look. I'll show you, oh, there we go. I'll show you here the actual model of the Fowler's toad, and then you can see, and this was done on a school 3D printer, so the commercial level ones that we will be using will be even higher quality than this, but it will give you a chance to look at it up close and check it out. Okay, there we go. All right, so here is the Fowler's toad, and this is one of the most common toads in the east coast of the U.S. here, but you can see from our models, put it live, full screen, there you go. Now you guys can see the level of detail. That's pretty amazing. Sorry, my navigating skills is a little funny from this angle. But look at those marks. So when you see it come by, check it out up close, and you'll be able to see just how incredible we went from photos, so live animals, photography, to the mesh, to this model, to a 3D print as well. And this platform is called Sketchfab, and it's kind of like the YouTube for 3D models. And it actually is ready, so if you have a headset for virtual reality, you can click the button down here and it prepares the file so that you can see it in more of a 3D kind of way. So pretty awesome here. Thanks for your patience as I get all this. So this is one of our models that we haven't even published yet. You guys are getting a sneak preview of some that are going to be released in the next few weeks here. This is a Cayman. Pretty awesome here. Yeah, craziness.
What's the real life size of that?
Little. It looks big though. I think it's about that big.
Oh.
Little tiny guy. But
Will you put a scale in with these and go, okay.
exactly. Yeah. So that's where that scientific metadata is going to be coming in. Something that we're working on adding. So when we scan it, we do have a scale that we've drawn on the substrate, and so that when it translates into 3D, we can give that sense of scale. Yes.
Does your metadata also contain maybe the DNA code so that
Careful, very fragile plastic.
One of the three things.
as cloning technology sort of improves,
As what was the last piece?
cloning technology improves, we could take that DNA signature and
I know, we're getting ready for Jurassic Park here.
I know.
Not quite there yet, but maybe in the future. I definitely would love to work with that. I think the more that we can integrate all the information into one platform, so one of the platforms I would really love to collaborate with in the future is Encyclopedia of Life. So there are other people, including National Geographic's Joel oh my goodness, I'm going to mess up his name. Anyways, a guy doing photo art at National Geographic. Amazing work photographing every species out there, and really, really high quality against a black studio background. But we're looking to do that with 3D photogrammetry. So adding in all these different components that people have been cataloging life on Earth, it would be amazing to just keep bringing it together. Yeah, awesome. I will show you a couple more models, and then we will break from our questions. So here's that frog that I was showing you, the Panamanian golden frog. Pretty freaking incredible. Wow. And it's actually cool because a lot of frogs have a shiny finish to them, a really glossy coat, and this one is actually matte. So when we modeled it, it really actually looks like the specimen, which is pretty amazing. And then this guy you actually saw in that video, the one that was like posturing and like hopping all over the place. That's this guy. He was a challenge to work with, to say the least. But then he ended up giving us this amazing posture here. And that's part of what we'll be working on as well, is really working with these animals to get them in a variety of poses that they would naturally create as well. Because that's part of the information that, you know, is valuable to capture, is what do they look like in the wild? How do they normally behave and pose? All right, cool. So the last thing I was going to show you guys here before we wrap up is for the Sea Turtles of the World, as you saw there, we just launched a fundraising campaign. Many of you guys were really drawn to the cause here. We have it, and I can give you the details for that to check it out. There's some awesome information and some great perks as well. So that 3D model that you saw there, you can get one of your own here. This is a really cool tub that we also printed out, but you can get an unpainted one, so you could paint it yourself and do it like a little art project. There's some perks with my fine art photography. You can get some prints that way, updates from the field, and then if any of you guys want to really join the effort in a big way, we're going to be hosting an exclusive event in Boston and New York at the end of this whole campaign to unveil all the models, and we'll do a demo with the Beastcam technology. We'll have the VR set up so that you can really see the animals and interact with them, with the models. So that's going to be a really, really fun event. So yeah, I think that about does it for today. And I had one last slide, but I think we're good. I think that's about it. So I'll leave it on there, and we can talk about questions and all of that. Thank you so much, guys. Yes.
One of your slides had NSF
technology was partially funded, the development of the technology was partially funded by an NSF grant that our lab of the director, Duncan Urship, his lab was awarded to work on this. Yeah. Awesome. Yes?
What type of 3D printer do you guys use?
What type of a 3D printer? Good question. I think it was a MakerBot is the one that they have at UMass, but we're also working with a couple of commercial printers to explore other ways to print them, different types of materials, and also calling all artists in the room, looking into casting as well. So creating some really interesting high-end ones with metal finishes and all of that as well. So yeah. Yes.
Do you think the movie industry would support you because you'd give them a better 3D for like 3D movies or something?
Mm-hmm. Yep, so that's actually something we're working on right now, is talking with some commercial entities as well as all the nonprofit sectors of ways that we can support them and kind of commercialize and license these models to support our mission. Yeah.
Why doesn't let him show his 3D model?
Yeah, I bought a couple.
Awesome, I would love to see. Yeah.
One's from Photogrammetry. It's Mamo. And it's the person that did the photogrammetry did it in the Bishop Museum. So a lot of people don't know the birds from the shore to the forest, they're all extinct. All the original birds are extinct. All the birds you see are all introduced. And so Bishop Museum has like drawers of the extinct birds, and the problem is they're not taxidermied or anything. So this one's got like a little bit of a question. I have another one that's like the skull, from sitting on side has collapsed. And this is more the, it's an Olala.
Was it really that small?
No, because 3D printing is very time consuming. So this probably was 3 or 4 hours.
Scaled down.
And I'm trying. I can't really do it myself, but if like the schools could get into it, you can do. There's multiple levels with 3D, low end, medium, real high end, and you can do photogrammetry if you have a good camera and you're patient. And if somebody start like contacting the museum, and that way then the big thing with 3D printing is it's empowering. So like if you have many of the museums are putting out 3D files of sculptures and things. So it used to be like you'd have to be a really wealthy person to have Venus de Milo. Everybody can have a Venus de Milo now.
Can you guys hear him on that side?
Yeah. That's what I'm just trying to. I don't have the initiative to do it, but just to let people know there's kind of like opportunities maybe for the schools, especially.
Yeah, there's definitely some activities that can be done. Learning how to do photogrammetry, and there are apps now where you can do it with your phone. You've seen that?
There's like that one where like you basically sit it and it rotates. That's the entire
Super cool.
I don't know what it's called.
It's really difficult because that's what the computer's only seeing dots. That's all it sees. So, and also the lighting, you can't use like really bright light. Yeah, it has to be a very uniform lighting. And generally, what works best is to walk around it multiple times. If you don't, that setup probably is what each camera's like 1,000.
Yeah, it's pretty crazy, but you can do it with if the subject matter is not moving, if your subject is not moving, you can do it with a single camera. And like he was mentioning, you just walk around the subject and you basically do circles at different heights. And the main thing is you want one picture to the next to have a lot of overlap. So a lot of the same information in those reference points so the computer, like you said, can only see points. It doesn't understand what exactly it is. So it's only by giving it lots of pieces of this puzzle to put together that it can stitch together the whole view. Does that encapsulate? Yeah.
Microsoft has an application where you can take the different photos and it'll patch them together. They've been kind of messing around with that. I don't know where it's at right now.
Yeah. limitations to the numbers of photos you can use, but there are definitely, check out, Autodesk, and also Capture Reality is one of the higher end, more expensive products, but there's a lot of software out there to work with.
The other thing that's going on is, this is called on the fly. It's calculating on the fly, and there's now called LiDAR. It's a light radar, and MIT just came out with a LiDAR was supposed to be about like the size of a digital chip, the camera chip, and about $10. So the big thing with that is the computers are going to develop 3D machine vision. So the computers will start recognizing volume, and that will help a lot of the calculations to create the actual model. There's problems with the light bouncing off. That's with photogrammetry. You have to make sure every one is in perfect focus. With an actual kind of a radar, you won't have to have that.
Amazing. Thank you so much for sharing all that. I'm sure there are more people that would like to learn more, but for the sake of time, I think we'll move to the next questions, but then maybe, those that are interested, we can gather around and talk some more and see those models up close. They're really beautiful.
Yeah.
Really beautiful. Yeah, Jen.
Two questions. First, how long does it take to from the time you have the setup all set up to having a 3D model that's 3D meshed and colorized and everything? How long does that whole process take?
Good question. So the setup time is a little bit to get the camera ready. The actual photo it's instantaneous. It's in just a second, but sometimes it takes a lot of tries for the animal to be in right posture and all of that, and get it to settle down. And that's where really working with educated, experienced animal handlers comes in handy, because they know the species and what makes them relax to stay put for just a second. A lot of different expertise coming in. And then the actual modeling process going through software, it can run anywhere from like half an hour to like a day, depending on how fast your computer is. So a lot of variables in how many photos you put in, how high resolution photos are. And then if you've done your photogrammetry really well, you don't have any post-production you really have to do. It's complete and pretty much ready to go. But sometimes there will be little errors in dark places like shadows and that sort of thing. So sometimes it takes an experienced 3D modeler then to patch little holes and that sort of thing in the mesh and cut it out just right if you're going to print it and prep it. So sorry, it's not a super clear answer on that, but that's a general idea of the timeline.
Exactly what I was going for. And then what does your lighting setup look like for some? I mean, obviously very diffuse lighting, but like with so many cameras from so many different angles, you don't want bright spots at all. Like, how do you do that? How do you handle that?
So it's something that I actually just did a trip out to Massachusetts about a month or two ago and was really trying to help these guys out in person to problem solve. How do you light the entire animal, but without having shining light into any of the cameras to mess up the photos? So right now we have several lights from above that we put a lot of diffusion material in front of, as well as the component that I added in once I got there was a lit platform. So we were actually, for the prototype, we'll build out our own things later, but we actually used a ceiling panel that was like this LED ceiling panel and just put diffusion material on top of it and have animals sitting on that. So that's where, those engineers and everybody thinking from all these different disciplines comes in handy to problem solve things like that of how do you light it very, very evenly. You don't want a lot of contrast. You don't want shadows, but also so that the light isn't shining into the cameras. So still working on it. But
once you go to the movie industry, they do fabulous lighting,
Exactly. Yeah.
Get a lighting director from one of the motion picture companies.
I would love to. If you know any that are interested in collaborating, I welcome them to come consult with us. That would be fabulous. Yes.
With the invention or discovery of GoPro, which is a really high resolution camera, instead of having 20 cameras or 30 cameras around, would it be easier to have 20 or 30 guys with a GoPro on to do a picture, the same type of picture?
So we actually have been exploring working with GoPro. There are some limitations in that the lens that's built in is a fisheye lens. So it creates a lot of distortion, which is the opposite of what you want for photogrammetry. You want to use, this is getting a little technical, but a focal length near 50 millimeters, and the GoPro is kind of the equivalent of like 10 to 15, I don't know the exact amount, but it's a very, very wide field of view. So there are some technical issues that make it not perfect, but it is good in a lot of senses because it's small, it's portable. So we're working with it. We haven't done any really great models yet with it, but I think we'll get there. Yeah, it's neat that there's so many tools out there, so many different cameras of all sizes and shapes and specialties right now to play around with. It's awesome. Sorry. Yes.
How do you scan the shark?
How did we scan the shark? So that one, we're going to be doing a full Sharks in Motion campaign 2018. That's where the underwater stuff is coming in handy. But this one was actually with Neil Hammerschlag, the shark researcher, for his methodologies. They bring the shark out of the water for just a couple minutes and put a pump in its mouth while they take biopsy measurements, that sort of thing. And it's like a NASCAR pit crew, doing all the samples and then get it back in the water. So while it was on the platform, Duncan was actually there, and we had a black tip that was very calm for some reason, and it was just chilling out, loving the Auction David water going over his gills, and it just stayed put, and he was actually able to walk with a single camera and get that. We did that with Discovery Channel on the ship, so we were very, very lucky that day that it worked out because they normally move a lot. But yeah, that one, and we did the whole thing where we flipped it over, did the dorsal and ventral views and stitched it. So yeah, we'll be doing a lot more sharks probably in about a year. Yeah. Awesome. Okay.
Question:
Yes.
You talk a lot about needing the animal to be stationary in one spot, but if you're only taking one single instantaneous image from all of the photos all at once, you should be able to capture it in some kind of action, right? So it should
Theoretically, yes, but it needs to be in frame.
Mhm.
So that's where the kicker is. So yes, if we were to build out, we're looking at different configurations beyond just this circle. The circle is really helpful because it's naturally what you'd be doing for other photogrammetry for a stationary object. So we're mimicking that, but like all stationary. But we're working with testing out different configurations that would allow the animal to move and capture it as it goes in motion, so we can have those different views of postures and that sort of thing. But yeah, it needs to be in frame and focused. So yeah, that's the other piece. Yeah.
Well, doesn't the movie industry it generates computer generated like dinosaurs? Could you do something like that and just fake it? I mean, once you have the original.
Were you paying attention at all? Real life.
Once you have the original data, you know what all of the texture and all that stuff is.
Yeah.
Take it from there and use a computer to generate what it would look like in a different. So, I don't know.
Yeah, I mean, there's a lot of possibilities of what can be done with the models once we've created them to go ahead and animate them and then add in more of that artistic perspective, I guess. But
Because you've done the hard part already. You've got the, the million pixels of something.
Yeah.
And the computer should be able to take a million pixels and do.
Yeah. Interesting ideas. Yes.
Yeah, so could you possibly do something like actually end up rigging it so you could do like a sort of like pie thing with the tiger and it could actually move and all that stuff?
Yeah. So that tiger, took the team a long time. I heard something like a couple years to really create that animal. Say that again?
And then the studio went under.
And then the studio went under. So obviously it's super realistic, and there's a lot of commercials out there that have 3D animals in it. But at this point, they're all artistic renderings. So our goal is to move in that direction where we can provide them with the base model that then they would animate and use for productions like that. Does that answer your question?
Yes.
Yeah, cool. Yes.
So this was kind of hinted before. I just wanted a more definitive answer.
Yeah.
Anatomy. So take the same animal and then go in layers like this.
The cross-section kind of
Yeah.
concept. Yeah, I think that would be super, super cool. I know they've done that sort of thing with, so obviously virtual reality, augmented reality is really developing quickly, and the biggest thing that they need right now as the technology gets better for the headsets is content and educational content. So I know they've done several great like human anatomy virtual reality experiences where you can go and interact with the different layers and that sort of thing. Yeah, at this point, it's not our focus because just doing the outsides of the animals is so complex in itself that it's more than full-time jobs for all of us with volunteering for this. So, yeah, but I think that would be definitely something that we'd love to explore in the future and would be incredible as a learning tool, obviously, to learn more about the anatomy. Right now, it's more just the morphology and, yeah. Awesome, yes.
Regarding like file size, how like what's the file size of maybe like 1 million faces?
Good question. Yeah, so the files for the actual 3D models are not huge. It's a few hundred megabytes.
Really?
Yeah. So compared to the photos, which are each photo is like tens of megabytes usually. Super high resolution cameras up to like 70 megabytes per file, but yeah, the actual 3D model, surprisingly, isn't that huge. And the biggest piece with it is that once we create it for public distribution and viewing online, because the internet's not quite as fast as what we want it to be quite yet for this sort of thing, we simplify the models down. We reduce the number of vertices and polygons in it so that to the point where it still looks just as sharp and accurate and interesting for our viewing, but it's easier for the computer and the internet to load it. So, yeah.
You say it's not very large. 200 megabytes sounds like every word that's ever been printed.
Yeah, I guess it's all on scale. We're coming from a media background where, yeah, just one simple little video clip is a few gigabytes. It's all relative, I guess. So, yeah, Alex and then.
Not all green sea turtles look the same.
Yes.
So, and scientists are often more interested in the variability between individuals than trying to define one standard need.
Yeah.
How much effort do you think you do? I know you're just getting started, but are you projecting yourselves forward into trying to capture multiple specimens of each?
Yeah, that's one of the exact questions that our founder, our director is most interested in, is variability from individual to individual, as well as life stages and sex, the male, female, and so that's exactly one of the questions we're looking to answer. Awesome. So if you guys are okay with it, we'll wrap up and then we can do individual questions. One last one?
What's your role? You're here in Hawaii, right? And this police cam is in Massachusetts. What are you doing? What's the coordination?
Yeah, so I've been, basically I was helping them a lot at the beginning with kind of business strategy, organizational strategy, and helping them develop a clear focused mission and how to carry that out. So kind of from the organizational side, operational side of things, and planning, but also consulting as far as figuring out how to do everything and do it better. So a lot of Skypes, a lot of phone calls, a lot of emails, all that sort of thing, and then a few trips out there. But as we're moving into these field expeditions, I'll be out on a lot of those field expeditions as the primary photographer. We'll have a scientist and a photographer for every expedition we do. So I don't know if that answers your question, but I do as much as I can while still enjoying paradise.
That's really simple.
Awesome. Thank you so much, guys. If you guys are interested in taking a quick look, we're pretty excited in that we just had an article in Nat Geo released for DigitalLife. So if you want to take a quick look, it's the May issue, and super cool. And if you didn't get a chance to see the model, I'm sure it's around. There it is. Yeah, awesome. I'll leave these guys both here for you guys to check out. And thank you so much. Enjoy.